February 14, 1943, 18,000 feet above Bougainville, Solomon Islands. The azure Pacific sky became a theater of technological revolution that would forever alter the balance of aerial warfare. Japanese naval aviation, masters of the sky since Pearl Harbor, encountered their nemesis in the form of a dark blue American fighter whose distinctive inverted gull wings would soon become synonymous with death itself. Like, comment where you're watching from, and don't forget to subscribe for more hidden World War II stories. The Vought F4U Corsair executed a vertical climb that defied every principle Japanese pilots understood about aerial combat. It rose past 20,000 feet, then 22,000, still climbing with power to spare, while the Mitsubishi A6M0, pride of the Imperial Japanese Navy, struggled at its operational ceiling. This was Whistling Death, named for the distinctive shriek its wing root oil coolers made in a dive. And within 18 months, this single aircraft type would psychologically annihilate the Imperial Japanese Naval Air Service's elite pilot corps. What occurred that Valentine's Day marked the beginning of systematic technological dominance that would transform Japan's most experienced aviators from hunters to hunted, from confident warriors to men who would deliberately flee combat upon spotting those unmistakable bent wings cutting through the sky. To comprehend the psychological devastation the Corsair inflicted, one must first understand the supreme confidence of Japanese naval aviators in early 1943. These were not ordinary pilots, but survivors of the world's most selective aviation training program. The Yokorin Naval Aviator Preparatory Course accepted fewer than 2% of applicants, a selection rate more stringent than modern astronaut programs. Those selected endured 3 years of training so rigorous it killed more candidates than the Americans lost in some major battles. Physical conditioning included swimming in rough seas, enduring exposure to extreme temperatures, and mental conditioning that bordered on torture. Candidates who showed weakness were dismissed or died trying to overcome it. By 1943, the average Japanese carrier pilot possessed over 800 hours of flight time. Many veterans of the China campaign boasted over 2,000 hours. Experience levels American pilots wouldn't achieve until late in the war. These aviators had revolutionized naval warfare at Pearl Harbor, where they demonstrated tactical innovations that left the world's naval powers reeling. They had stunned the British at Ceylon, sinking the aircraft carriers HMS Hermes and HMS Eagle with surgical precision. They dominated skies from Burma to the Gilbert Islands, creating an aerial empire spanning thousands of miles. The statistics from 1942 told the story of their dominance. The Mitsubishi A6M0 achieved a staggering 12-to-1 kill ratio against Allied fighters. This wasn't mere technological superiority. It represented a fusion of exceptional aircraft design, superior pilot training, and tactical innovation that made Japanese naval aviation the world's most feared air force. The Mitsubishi A6M0 embodied Japanese aviation philosophy: maximum performance through minimum weight. Chief designer Jiro Horikoshi created an aircraft that prioritized maneuverability and range over protection and firepower. Every unnecessary gram was eliminated. The aircraft carried no armor plating, no self-sealing fuel tanks, and minimal structural redundancy. The result was a fighter that could turn inside any Allied aircraft and possessed the range to escort bombers across vast Pacific distances. In the hands of experienced pilots, the Zero seemed nearly invincible. It could execute a 360-degree turn in just 16 seconds at combat speeds, a performance that wouldn't be matched by American fighters until war's end. Its exceptional range of 1,929 miles allowed Japanese carriers to strike targets previously thought beyond reach, while its climb rate of 2,750 feet per minute gave it tactical flexibility that American pilots could only envy. Japanese pilots had developed energy tactics that maximized their aircraft's strengths. They understood how to convert altitude into speed, how to use the Zero's exceptional low-speed handling for defensive maneuvers, and how to exploit its remarkable visibility. The aircraft's greenhouse canopy provided 360-degree vision that gave pilots crucial situational awareness. The Zero's armament, while lighter than contemporary fighters, was carefully chosen. Two 7.7mm machine guns provided high rates of fire for initial attacks, while two 20mm cannons delivered devastating stopping power. The cannon's low velocity made them difficult to aim, but in the hands of experienced pilots who understood deflection shooting, they were lethal. When Marine Fighting Squadron 124, VMF 124, brought the first 12 F4U Corsairs to Guadalcanal on February 12, 1943, Japanese reconnaissance immediately noted the new aircraft's distinctive appearance. The inverted gull wings weren't merely aesthetic. They solved complex engineering problems that Japanese designers hadn't even recognized. The wing configuration allowed the massive propeller to clear the ground while keeping the main landing gear short and light. The 13-foot, 4-inch diameter propeller, the largest ever fitted to a fighter, required this innovative solution. This seemingly simple design choice revealed American engineering sophistication that went far beyond Japanese capabilities. The first combat encounter on February 14th, initially dubbed the St. Valentine's Day Massacre, proved disastrous for the Americans. 9 Allied aircraft lost versus 10 destroyed. However, this engagement revealed something that chilled Japanese pilots to their core. These new fighters possessed performance characteristics that fundamentally changed aerial combat dynamics. The Corsairs didn't engage in traditional turning fights. Instead, they climbed above the Zeros, something no American fighter had previously managed, and executed high-speed diving attacks. They used their massive speed advantage to escape before Japanese pilots could respond. Then zoom climbed back to altitude, completely immune to pursuit. Japanese intelligence officers gradually assembled the Corsairs' technical specifications, revealing an overwhelming disparity in capability that represented not just an improvement, but an entirely different category of aircraft. Power plant revolution. The Pratt & Whitney R280018WW double wasp engine produced 2,000 horsepower on takeoff, with water injection boosting it to 2,250 horsepower in combat emergencies. The Zero's Nakajima Sakai 21 engine managed 1,130 horsepower at takeoff. This wasn't merely a power advantage. It represented American mastery of complex engineering that Japan couldn't duplicate even with captured examples. The R2800 featured 18 cylinders arranged in 2 rows, precision engineered to tolerances measured in thousandths of an inch. Its 2-speed, 2-stage supercharger maintained power at altitudes where Japanese engines gasped for air. The engine alone weighed 2,360 pounds, nearly half the weight of an entire Zero, yet produced double the power of Japan's best efforts. Speed, the ultimate tactical advantage. Maximum speed revealed the disparity most starkly. The Corsair achieved 417 miles per hour at 19,900 feet, while the Zero Model 52, Japan's latest variant in 1943, managed 351 miles per hour at best altitude. In level flight, this meant Corsair pilots could choose when to engage and when to flee, fundamentally altering combat dynamics. In a dive, the difference became terrifying. Corsairs routinely exceeded 500 miles per hour while maintaining perfect control, thanks to their robust construction and sophisticated control systems. Zeros experienced control surface flutter at 360 miles per hour and catastrophic structural failure above 410 miles per hour. Japanese pilots learned to dread the moment a Corsair entered a dive, knowing they couldn't follow without risking their aircraft's disintegration. Climbing into dominance, the climb performance gap was equally devastating. The Corsair reached 20,000 feet in 7.7 minutes with a standard climb rate of 2,890 feet per minute. War emergency power increased this to 3,210 feet per minute. The Zero required 11 agonizing minutes to reach the same altitude, during which Corsair pilots could position themselves for devastating attacks. Above 25,000 feet, where Corsairs remained powerful and responsive, Zeros became sluggish and barely controllable. The American fighter's service ceiling of 36,900 feet might as well have been outer space to Japanese pilots whose aircraft struggled above 33,000 feet. Firepower, the weight of metal. The armament difference proved psychologically devastating. The Corsair carried 6 Browning M2.50 caliber machine guns, each firing 850 rounds per minute with a muzzle velocity of 2,840 feet per second. The total weight of fire reached 69 pounds of metal per second. enough to saw a Zero in half with a brief burst. The Zero's two 7.7mm machine guns and two 20mm cannons delivered only 13 pounds per second, and the cannons carried merely 60 rounds per gun, enough for 7 seconds of firing. Worse, the 20mm shells had low muzzle velocity and significant bullet drop, making them effective only at close range against maneuvering targets. Japanese pilots discovered that Corsairs were nearly indestructible compared to their unarmored Zeros. The F4U carried 155 pounds of armor plate around the cockpit, self-sealing fuel tanks that prevented fires, and armored oil coolers that protected critical systems. Cannon shells that would obliterate a Zero merely damaged Corsairs, which often returned to base with hundreds of holes but still flying. This survivability transformed combat psychology. American pilots could be aggressive, even reckless, knowing their aircraft would forgive errors. They could press attacks, absorb damage, and return to fight another day. Japanese pilots had one chance. One mistake meant death. Their aircraft, built for maximum performance through minimum weight, offered no protection against the inevitable errors of aerial combat. The Zero's legendary maneuverability came at the ultimate price. No armor meant that any hit could be fatal. No self-sealing tanks meant that fuel fires were inevitable. Structure cut to minimum weight meant that high-G maneuvers could cause structural failure. The Zero achieved its performance by accepting risks that American engineers refused to tolerate. Rabaul, Japan's fortress in the southwest Pacific, became the stage for the Corsair's systematic demolition of Japanese naval aviation. Here, at Japan's most powerful base outside the home islands, the cream of Japanese fighter units concentrated to stop the American advance. The base featured 5 airfields, sophisticated radar networks, and underground hangar complexes that could protect hundreds of aircraft. By October 1943, when Major Gregory "Pappy" Boyington's VMF 214 Black Sheep Squadron arrived with their F4U Corsairs, the psychological balance had already shifted. Japanese pilots no longer spoke of victory, but of survival. The confident warriors who had dominated the sky since Pearl Harbor now huddled in briefing rooms, discussing escape routes and survival tactics. The December 17th massacre. On December 17, 1943, Boyington led 31 Corsairs as cover for a bombing raid on Rabaul. The Japanese launched 40 Zeros to intercept, their best pilots in their newest aircraft, representing the Empire's final hope for aerial supremacy. What followed demonstrated the Corsairs' complete dominance in stark mathematical terms. The Corsairs climbed to 25,000 feet, an altitude where Zeros struggled to maneuver effectively. When the Japanese climbed to engage, the Americans dove through their formation at speeds approaching 450 miles per hour, fired quick, devastating bursts, and Zoom climbed back to altitude. The Zeros, unable to follow, unable to escape, unable to force the close combat where their maneuverability might matter, watched helplessly as their numbers dwindled. The engagement lasted less than 20 minutes. 11 Zeros fell from the sky, their pilots killed or captured. 2 Corsairs suffered minor damage, but returned safely to base. The mathematical brutality of the exchange, 11-0 in terms of aircraft destroyed, represented more than tactical victory. It demonstrated complete technological obsolescence. The Corsair's psychological impact went far beyond performance statistics. The aircraft's distinctive sound became a weapon itself, seared into the memory of every Japanese pilot who survived an encounter. The oil cooler intakes in the wing roots created an unforgettable whistling shriek during high-speed dives, a sound that Japanese pilots reported hearing in their sleep, developing involuntary reactions when similar noises occurred. American pilots deliberately enhanced this psychological warfare. They would make terror dives without firing, creating the whistling sound over Japanese airfields just to unnerve ground crews and pilots. The Black Sheep Squadron painted shark mouths on their Corsairs, enhancing the predatory image that haunted Japanese nightmares. The Corsair's appearance amplified this terror. The inverted gull wings created a predatory silhouette unlike any other aircraft, a mechanical bird of prey that Japanese pilots learned to fear more than death itself. The massive propeller, dark blue paint scheme that made it nearly invisible against the sea when diving from above, and the aggressive stance of the aircraft on the ground all contributed to its intimidating presence. Saburo Sakai's testament. Saburo Sakai, Japan's most famous surviving ace, with 64 victories, provided perhaps the clearest assessment of facing corsairs in his post-war writings. Sakai, who had shot down his first enemy aircraft over China in 1938 and survived the entire war, described recognizing that the war was lost upon encountering the Corsair, not because of one aircraft, but because America could build such aircraft by the thousands while Japan struggled to maintain existing designs. Sakai noted that survival against Corsairs required avoiding engagement entirely. When Japanese pilots spotted the distinctive bent wings, they would dive for the deck, flee to clouds, or use any available cover to avoid combat. This wasn't cowardice, but recognition of mathematical reality. Fighting a Corsair in a zero had become suicide, and dead pilots couldn't protect Japan. By mid-1943, Japan faced a terrible equation that would determine the war's outcome. Corsairs and other advanced American fighters were killing experienced pilots faster than Japan could train replacements. The carefully constructed system that had produced the world's finest naval aviators collapsed under the weight of constant attrition. Pre-war Japanese naval aviators received 500 to 700 hours of flight training before combat assignment. This extensive preparation created pilots who understood their aircraft intimately, had developed exceptional situational awareness, and possessed the skills necessary for complex tactical maneuvers. By 1943, fuel shortages and training aircraft losses had reduced this to 150 hours. By 1944, new pilots arrived with as little as 100 hours. By 1945, desperate Japanese commanders were sending teenagers into combat with 40 to 60 hours of total flight time. These replacement pilots were barely able to handle their aircraft in normal flight, let alone engage in high-speed combat against Corsairs. They hadn't fired their guns in training, never experienced high-altitude combat, and had no understanding of energy management tactics. They were, in the brutal calculus of aerial warfare, lambs being led to slaughter. The psychological impact on veteran pilots proved devastating. They were paired with novices who had no chance against Corsairs, forced to watch them die while trying to protect them. The traditional mentor system, where experienced pilots guided newcomers through their first combats, collapsed under the weight of constant losses. Veterans who had survived hundreds of combat missions found themselves flying with pilots who died in their first encounter with the enemy. The Battle of the Philippine Sea in June 1944 demonstrated the prediction's accuracy in what Americans mockingly called the Great Marianas Turkey Shoot. F-6F Hellcats, sharing the Corsair's engine and similar performance characteristics, achieved kill ratios that defied belief. Approximately 400 to 450 Japanese aircraft were destroyed versus 130 American planes lost. Many Japanese pilots never even saw their killers, shot down by fighters they couldn't climb to engage or escape from in dives. The engagement revealed the full impact of America's industrial approach to warfare. While Japan scraped together pilots and aircraft from across the Pacific, the Americans deployed fresh squadrons with factory-new aircraft flown by pilots who had received more training in 6 months than many Japanese veterans accumulated in years of combat. The mathematics of destruction. Lieutenant Robert Hansen's extraordinary record exemplified the Corsair's dominance. Flying with VMF-215, Hansen destroyed 20 Japanese aircraft in just 17 days, between January 14th and 30th, 1944. His success wasn't due to exceptional skill alone, but to the systematic exploitation of the Corsair's overwhelming advantages. Hansen's tactics became standard operating procedure for Corsair pilots. Climb to altitude advantage, identify enemy formations, execute high-speed diving attacks, fire brief but devastating bursts, and zoom climb to safety before the enemy could respond. Japanese formations learned to scatter upon identifying approaching Corsairs, abandoning their missions rather than face certain destruction. As 1943 progressed into 1944, improved variants of the Corsair widened the performance gap even further. The F4U introduced a bubble canopy for better visibility, water injection for combat power increases, and improved armor protection. The pilot's visibility, previously limited by the long nose, improved dramatically with the new canopy design. The F4U variant could carry 4,000 pounds of bombs, more than many Japanese bombers, while still outperforming any Japanese fighter. This multi-role capability meant Corsairs could appear anywhere, anytime, in any role, adding strategic uncertainty to tactical terror. Japanese commanders never knew whether approaching Corsairs carried bombs for ground attack, rockets for shipping strikes, or were configured purely for air-to-air combat. Night fighter variants. Darkness offers no sanctuary. The deployment of F4U night fighter variants in 1944 added a new dimension of terror that shattered Japanese pilots' psychological defenses completely. Equipped with APS-4 airborne radar, these 36 specially modified Corsairs hunted Japanese aircraft in darkness, previously Japan's only sanctuary from Allied air power. The psychological impact of being hunted in darkness by an invisible predator armed with radar destroyed the last vestiges of Japanese pilot confidence. Night had been the time for recovery, resupply, and brief respite from the constant threat of Corsair attacks. The night fighter variants eliminated even this refuge, creating a psychological prison where death could strike at any moment, from any direction, without warning. Japanese attempts to counter the Corsair revealed their technological desperation and growing industrial inadequacy. The Zero Model 52 added armor plating and self-sealing fuel tanks in response to combat experience, but these modifications made the aircraft so heavy it lost its crucial maneuverability advantage without gaining meaningful survivability. The new Kawanishi N-1K George fighter showed promise with better armor, heavier armament, and improved performance, but suffered from unreliable engines and complex hydraulic systems that failed constantly. Japanese industry, already strained beyond capacity, couldn't produce engines with the precision tolerances required for high-performance combat aircraft. The Mitsubishi J2M Jack represented Japan's attempt to build a pure interceptor optimized for climbing and speed rather than maneuverability. While it achieved better performance than the Zero, it remained inferior to the Corsair in every measurable category except perhaps initial climb rate at sea level, a narrow advantage that provided little tactical benefit. The ultimate psychological defeat came with the adoption of kamikaze tactics in late 1944. This transformation from warriors seeking victory to pilots seeking only meaningful death represented complete acknowledgement of technological defeat. Vice Admiral Takijiro Onishi, architect of the kamikaze program, privately admitted the true reason for suicide attacks. Conventional combat against Corsairs and Hellcats had become impossible. By late 1944, the exchange ratio had reached 15-1 in favor of American fighters. Rather than die meaninglessly in hopeless aerial combat, Japanese pilots would attempt to die with purpose by crashing into American ships. The kamikaze program represented the final admission that Japanese aviation technology, training, and tactics had been completely superseded by American industrial might. This decision haunted Japanese aviation leadership. Admiral Jisaburo Ozawa, commander of the Combined Fleet's air arm, later wrote that ordering young men to commit suicide was the most difficult decision of his life. These weren't cowards seeking easy death, but brave young men acknowledging that conventional combat had become futile. The Corsair represented American industrial might in its most concentrated form. Vought aircraft produced 12,571 Corsairs during the war, more than Japan's total fighter production from 1942 to 1945. Each Corsair contained 13,000 pounds of aluminum, 1,000 pounds of steel, 18 miles of electrical wire, and 2,000 individual instruments and controls. The Pratt & Whitney R2800 engine alone demonstrated American industrial supremacy. With 2,800 cubic inches of displacement, 18 cylinders arranged in 2 rows, sophisticated supercharging, and precision engineering tolerances Japan couldn't achieve. It represented technology beyond Japanese capability to copy even with captured. Examples: training. Mass production of skill. While Japan scraped the bottom of its manpower barrel, sending teenagers with minimal training to face Corsairs, America mass-produced pilots with industrial efficiency. The U.S. Navy trained 60,000 pilots during the war, each receiving 600 hours of flight training, including 200 hours in advanced fighters. American pilots arrived in the Pacific having fired more ammunition in training than most Japanese pilots fired in their entire combat careers. They studied gun camera footage, analyzed combat reports, and underwent continuous tactical evolution. The American training system treated pilot development as an industrial process, with standardized curricula, measurable outcomes, and continuous improvement. Training facilities across America operated around the clock. Pensacola, Corpus Christi, and dozens of other bases became pilot factories that produced aviators with mechanical regularity. Advanced training included gunnery practice against radio-controlled targets, formation flying in weather conditions, and high-altitude combat techniques that Japanese pilots never experienced. The Battle of Okinawa in April to June 1945 provided the Corsair's final demonstration of superiority. Marine and Navy Corsairs flew from escort carriers and captured airfields, establishing complete air supremacy over the last major Japanese base outside the home islands. The statistics from Okinawa reveal the scale of dominance. Corsairs flew over 15,000 combat sorties, claimed over 500 aerial victories, and delivered thousands of tons of ordnance. Japanese pilots arriving at Okinawa, many with fewer than 30 hours of flight training, faced systematic destruction that resembled industrial processing more than combat. The few survivors described engagements lasting seconds. They never managed to point their guns at the Corsairs that destroyed them. Planning for Operation Olympic. As Japan prepared for invasion of the home islands, the reality of facing thousands of Corsairs created strategic paralysis. Japanese planners calculated that Americans could deploy over 5,000 Corsairs from carriers and captured airfields. Against this armada, Japan could muster perhaps 2,000 flyable aircraft of all types, most obsolete designs flown by pilots with minimal training. Admiral Soemu Toyoda, Commander-in-Chief of the Combined Fleet, later acknowledged that conventional air combat had become impossible. The only remaining strategy involved hiding aircraft for suicide attacks, a final admission that the Japanese could no longer contest American air superiority through conventional means. When atomic bombs ended the war in August 1945, they spared Japanese aviation from final annihilation. Plans existed for Operation Olympic, the invasion of Kyushu, where over 2,000 Corsairs would have operated from 48 carriers and dozens of captured airfields. Japanese pilots who survived expressed relief at avoiding this final confrontation, describing it as potential extermination rather than combat. In the immediate post-war period, American occupation forces brought Japanese military leaders to observe American aircraft factories. The Vought plant in Connecticut, still producing Corsairs, revealed the true scale of American industrial capacity that had made their defeat inevitable. Single American factories produced more aircraft engines than all of Japan combined. Individual American states possessed more aluminum production capacity than the entire Japanese empire. Former Japanese naval officers observing these production lines finally understood the impossibility of their wartime position. They had challenged an industrial superpower with pre-industrial capacity. The revelation was psychologically devastating. These were men who had planned Pearl Harbor, who had believed Japanese spirit could overcome American material. Standing in factories that dwarfed anything in Japan, watching production lines that could build Corsairs faster than Japan could train pilots to fly Zeros, they finally comprehended the futility of their cause. The final statistics of Corsair operations in the Pacific War tell a story of complete technological domination that reshaped military thinking permanently. Total Corsairs produced 12,571 total aerial victories, 2,140 air-to-air combat losses, 189 kill ratio 11.3 to 1. Combat missions flown, over 64,000 bombs dropped, 15,621 tons. But these numbers understated the psychological devastation. Many Japanese aircraft fled without engaging when Corsairs appeared. Others were destroyed on the ground by marauding Corsairs before they could take off. Countless pilots refused to fly when Corsairs were reported in the area, creating a paralysis that extended far beyond direct combat losses. The Corsairs' dominance shattered fundamental aspects of Japanese military culture that had evolved over centuries. The concept of Yamato Damashi, the unique Japanese spirit that would overcome material disadvantages, proved hollow against overwhelming technological superiority. Traditional emphasis on individual warrior skill became meaningless when skill couldn't overcome performance disparities that bordered on the supernatural. Civilizational impact. The most experienced Japanese ace, flying the most perfectly maintained Zero, had no chance against an average American pilot in a Corsair. This reality destroyed the philosophical foundation of Japanese military training, and by extension, Japanese society's understanding of its place in the modern world. The Corsair's influence on post-war Japanese society cannot be overstated. The complete failure of spiritual strength against American technology helped discredit militaristic ideology and prompted Japan's embrace of technological modernization that would transform it into an economic superpower. The F4U Corsair proved daily to thousands of Japanese that their entire worldview was wrong. Spirit could not overcome technology, will could not defeat industry, and courage meant nothing against overwhelming mechanical superiority. The statistical dominance of the Corsair tells only part of the story. Behind every number was a human being whose world was fundamentally altered by encounters with American industrial might made manifest in aircraft form. These personal accounts reveal the true psychological impact of facing technological obsolescence in aerial combat. Lieutenant Commander Minoru Genda's awakening. Minoru Genda, architect of the Pearl Harbor attack and one of Japan's most brilliant tactical minds, first encountered Corsairs over the Marshall Islands in early 1944. Flying a Zero himself, something rare for staff officers, Genda found himself pursued by two F4U-1Ds that climbed above his aircraft with casual ease. I realized at that moment, Genda wrote in his diary, that everything we had built, everything we believed about air combat, was obsolete. These aircraft didn't just outperform ours, they existed in a different realm of possibility. It was like comparing a samurai sword to a machine gun. Both are weapons, but one represents the end of an era. Genda's experience was particularly significant because he understood the strategic implications immediately. As one of Japan's premier aviation strategists, he recognized that the Corsair represented not just tactical superiority, but proof of American industrial capacity that Japan could never match. His post-mission report to Admiral Yamamoto was devastating in its honesty. "We are no longer fighting an enemy air force. We are fighting an industrial empire." The last flight of Lieutenant Tetsuzo Iwamoto. Tetsuzo Iwamoto, Japan's third highest scoring ace with 80 confirmed victories, faced his final combat mission against Corsairs over Rabaul on February 3, 1944. Iwamoto, a veteran of campaigns from China through the Solomon Islands, had developed tactics specifically for engaging American fighters. His experience fighting F-4F Wildcats and early P-40S had given him confidence in Japanese superiority. The engagement began routinely. Iwamoto led 8 Zeros against 12 Corsairs, escorting B-25 bombers. Using traditional Japanese tactics, he attempted to draw the Americans into a turning fight where the Zero's maneuverability would dominate. The Corsairs refused to engage on Japanese terms. Instead, they climbed to 28,000 feet, an altitude where Iwamoto's Zero became sluggish and unresponsive. From there, they executed diving attacks at speeds Iwamoto had never experienced. "The Corsairs came down like thunderbolts," he recorded in his final mission report. "By the time you heard the whistle, the attack was over. By the time you could react, they were climbing back to altitude, completely beyond our reach." Iwamoto's Zero was hit by 3 separate diving attacks. Cannon shells shredded his wings, destroyed his instruments, and wounded him in the leg. Only his exceptional flying skill allowed him to crash land at Rabaul. He never flew combat again, not due to his injuries, but because the psychological impact of complete helplessness had destroyed his confidence. "I had fought Chinese pilots, British pilots, American pilots," Iwamoto wrote years later. "I understood aerial combat, but the Corsair pilots weren't engaging in combat. They were conducting execution. They had such overwhelming advantages that skill became irrelevant. It was like fighting gravity itself." Ensign Kiyoshi Ito's transformation. 19-year-old Ensign Kiyoshi Ito arrived at Truk Atoll in March 1944 with 120 hours of flight training, considered well prepared by 1944 standards, but woefully inadequate compared to pre-war requirements. His first combat mission was a scramble to intercept B-24 Liberators approaching the base. Ito never saw the bombers. His 4-plane section was intercepted by 6 Corsairs from VMF 321 that appeared as if from nowhere, diving from 30,000 feet at speeds that seemed impossible. The engagement lasted less than 2 minutes. 3 Zeros were destroyed, their pilots killed instantly. Ito survived only because his engine quit, forcing him into a dead-stick landing that the Corsairs apparently deemed not worth pursuing. "I sat in my cockpit after landing, shaking uncontrollably," Ito recalled decades later. "Not from fear, from the realization that I had been completely outmatched. The Corsairs moved like nothing I had seen in training. They controlled every aspect of the engagement, when it began, how it proceeded, when it ended. We might as well have been flying training aircraft against frontline fighters." Ito flew 17 more missions over the next 3 months, each one reinforcing his understanding of Japanese technological obsolescence. He developed what he called Corsair Sense, the ability to detect the distinctive engine sound that announced approaching doom. By June 1944, he could identify Corsairs by engine sound alone from over 10 miles away. The psychological stress of flying missions while knowing that encountering Corsairs meant probable death created what military psychologists today would recognize as combat trauma. Ito began experiencing nightmares about the Corsair's whistle, involuntary reactions to certain sounds, and periods of disorientation during flight. He wasn't alone. Similar symptoms appeared throughout Japanese fighter squadrons as the war progressed. The technological gap between the Corsair and Zero represented more than different design philosophies. It revealed the fundamental differences between American and Japanese industrial capabilities that would determine the war's outcome. The R2800, Double Wasp, Engineering Excellence, the Pratt & Whitney R2800. Double Wasp engine represented the pinnacle of American aviation engineering in 1943. Its development required advances in metallurgy, precision manufacturing, and quality control that stretched American industry, but remained within achievable limits. Each engine contained over 3,000 precisely machined parts, including cylinders with bore tolerances measured in 10,000ths of an inch. The engine's 2-speed, 2-stage supercharger was a masterpiece of mechanical engineering. It maintained sea-level power output to 21,000 feet, then smoothly transitioned to high-altitude performance that kept the engine producing substantial power above 30,000 feet. The supercharger alone required precision gear-cutting equipment that Japan didn't possess, and metallurgical knowledge that remained beyond Japanese capabilities, even with captured examples to study. Water methanol injection boosted combat power to 2,250 horsepower for brief periods, providing Corsair pilots with emergency performance that could determine the outcome of engagements. The injection system required sophisticated metering, precise mixture control, and anti-detonation additives that Japanese chemists couldn't duplicate with available materials. Perhaps most remarkably, the R2800 achieved this performance while maintaining reliability that allowed engines to operate for hundreds of hours between major overhauls. Japanese engines of equivalent power, when they could produce it, typically required complete rebuilds after 50 to 100 hours of operation. The Zero's elegant limitations. In contrast, the Mitsubishi Zero represented elegant engineering, constrained by material limitations and manufacturing capabilities that revealed Japan's industrial weaknesses. Chief designer Jiro Horikoshi created an aircraft that maximized performance within strict weight and material constraints. The Zero's structure utilized a revolutionary semi-monocoque design that distributed loads efficiently while minimizing weight. Horikoshi's team developed innovative construction techniques that bonded aluminum sheets to internal frames using methods that created structures stronger than the sum of their parts. However, these techniques required hand-fitting and craftsmanship that made mass production impossible. Each Zero required approximately 15,000 man-hours to complete, nearly 3 times longer than a Corsair. Skilled craftsmen had to hand-fit major components, adjust control surfaces individually, and perform final assembly with tolerances that required experienced judgment rather than precision tooling. This craftsmanship approach produced excellent individual aircraft, but couldn't achieve the production rates necessary for industrial warfare. The Zero's Nakajima Sakai 21 engine represented the limits of Japanese engineering capability in 1943. While reliable and fuel-efficient, it achieved only 1,130 horsepower, due to metallurgical limitations that prevented higher compression ratios and boost pressures. Japanese steel couldn't withstand the thermal and mechanical stresses required for higher power output, and precision manufacturing equipment wasn't available to achieve the tight tolerances necessary for advanced supercharger designs. Manufacturing philosophy: craftsmen versus engineers. The fundamental difference between American and Japanese aircraft production revealed contrasting approaches to modern manufacturing that extended far beyond aviation. American factories emphasized standardization, interchangeable parts, and production line efficiency that allowed relatively unskilled workers to assemble complex aircraft with consistent quality. Corsair production at the Vought plant in Stratford, Connecticut, represented industrial engineering at its finest. Each aircraft moved through precisely timed stations where specialized workers performed specific tasks with tools designed for maximum efficiency. Parts were manufactured to tolerances that guaranteed interchangeability. Any wing could fit any fuselage, any engine could mount in any airframe. Quality control relied on statistical methods and precision measuring equipment rather than individual craftsman judgment. Finished aircraft rolled off production lines with performance characteristics that varied less than 2% between individual examples. This consistency meant pilots could transition between aircraft without adapting to individual quirks or performance variations. Japanese production remained rooted in traditional craftsmanship approaches that emphasized individual skill and attention to detail. Master craftsmen trained apprentices through years of hands-on experience, passing along techniques that couldn't be systematized or transferred to less skilled workers. This approach produced exceptional individual aircraft, but couldn't achieve the production rates necessary for total war. War, 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 war.